Welcome to session 10, volume of boxes and cubes. We will build the idea visually, solve a complete example, and finish with a short independent check. By the end, you will be able to model volume as layers of unit cubes, calculate rectangular prism and cube volume with cubic units, find a missing dimension when volume and two dimensions are known. Keep the diagram, the calculation, and the unit connected at every step. Start with the concept visual. The A cube's equal dimensions produce side cubed. The A net contrasts outside covering with inside capacity. We read every label as evidence about what is known, what is unknown, and which measurements actually belong in the model. Here's the central reasoning. A storage bin measuring 6 feet by 4 feet by 3 feet holds 72 feet cubed. If its length doubles while width and height stay fixed, its capacity doubles to 144 feet cubed. Box volume counts unit cubes arranged in layers. Length times width gives cubes per layer, and multiplying by height counts how many identical layers fill the solid. Draw or imagine a cross-section and decide whether you are filling the solid or covering it. This separates cubic volume from square surface area. Now add a precision check. For a solid, mark the base and the perpendicular height, then separate flat faces from curved surfaces. Keep pi or other exact values through intermediate steps. If the object is open, attached, or partly hidden, count only the faces the context says are exposed or filled. A complete line of work should make the diagram, formula, substitution, arithmetic, unit, and conclusion easy for another learner to audit. Use this repeatable method. First, confirm that length, width, and height use the same unit. Second, multiply the base rows and columns to find cubes per layer, then multiply by the number of layers. Third, for a missing height, rearrange to h equals v divided by LW. Finally, check that changing one dimension changes volume by the same scale factor. Do not skip the final check simply because the calculator produced a number. Let us model a complete example. A rectangular box is 8 by 4 by 6. What is its volume? Step 1 is to organize the information. Confirm that length, width, and height use the same unit. Step 2 chooses and sets up the relationship. Multiply the base rows and columns to find cubes per layer, then multiply by the number of layers. Step 3 carries out the mathematics. Box volume is length x width x height. 8 times 4 times 6 equals 192. A useful check is to volume multiplies all three dimensions. The answer is 192 cubic units. Now verify the result against the original wording. The quantity, numerical size, and unit must all make sense together. Now it is your turn. Cube has side length 7. What is its volume? Write a formula or relationship before calculating, then use the next 6 seconds to finish your reasoning. The model answer is 343 cubic units. Cube volume is side cubed. 7 cubed equals 343. A useful check is to surface area is 6 squared, but volume is cubed. Use this coaching check as well. Name the 3 multiplied dimensions before calculating. Using only 2 dimensions produces area, not volume. Session recap. First, confirm that length, width, and height use the same unit. Next, multiply the base rows and columns to find cubes per layer, then multiply by the number of layers. Then, for a missing height, rearrange to h equals v divided by LW. Finally, check that changing one dimension changes volume by the same scale factor. A strong geometry solution is more than arithmetic. It identifies the requested quantity, represents the structure, calculates carefully, and checks the meaning of the result. Carry that full habit into the next session.